Hello friends, me again, your favourite maths teacher's right hand, and I want to show you something. I want to show you what's got to be the most popular graph of 2020. This one, the old flattening the curve graph. I've seen this 100 times on TV this year. You may never see it again. Hopefully we'll never see it again after this year, but we're seeing it all the time at the moment without protective measures, with protective measures, and that's the healthcare system capacity, and that's why we had to get protective measures like social distancing and so forth so that the hospitals could handle things. And sure enough, we started seeing this in February. And since February, in March, we were seeing graphs like this with everything rising and all the news was bad. But now the countries that have done the right thing are starting to see graphs like this with deaths and incidences of coronavirus going down. We're heading the other side. Right? But how did these guys back in February, back in January, know that this was going to happen? How did they know that if we didn't do anything right, that was going to happen? And if we did do everything right, this was going to happen and most of us would be okay? They only saw that. How did they know that the rest of this was going on? Well, they're good at spotting a pattern and using a pattern to predict things. And that, my friends, is today's skill. This is being used all over the world at the moment. This and many other skills are being used all over the world, literally to save us. Right? We're never going to forget this year, and this is has been one of the stars of the year. We're never going to get this image out of our mind. And your training on how to spot a pattern and use it to predict the future starts right now. Now, because this is the beginning, we're going to start fairly easy. We're not going to worry about graphs or anything like that. We're just going to worry about sequences of numbers. Excuse me. So here's a sequence of numbers, and you've got two skills that you're going to learn about this today. Firstly, finding a pattern in that sequence of numbers, finding some sort of schedule or some sort of trend that they're following. And secondly, using that pattern to see what comes next, to predict it before you can see it. Right? They're the two things you're learning today. This is what I want you to become an expert at by the end of the day. So I'm just going to show you a couple of easy ones here, right? 20, 17, 14, 11. How are they changing? Is there the same change every time, right? And you've probably already figured it out. 20 minus 3 is 17, 17 minus 3 is 14, 14 minus 3 is 11, right? Not that difficult. Keep on taking 3 off. Take another 3 off, take another 3 off. They're the next two numbers, right? Pretty straightforward, right? Another one here, 3, 6, 12, 24. That's adding 3, but then that's not adding 3, so I was wrong about this, right? So that can't be it, right? It has to be the same change. In order to be a pattern, it has to be something that's predictable, right? But that is also multiplying by 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. That's it, right? That's the pattern. So now we know what to do to get the next two. Double the next one, double the next one. Trust me, that's double 24 and that's double 48, right? That's reasonably easy, but this is a little bit sort of trial and error and sort of, calling it as you see it. And if you bark up the wrong tree, you can be here for a long time unless it really jumps out of you straight away. But there is a sequence of clues, a little bit of detective work that you can do to methodically find a pattern and then predict what's going on. So here are the rules. Let's stick them up here so we can still have a bit of room here. This is the clue list. Whenever you see a sequence of numbers and the job is to find a pattern and then use that pattern to figure out what comes next, this is what you should do in that order, right? So I'm going to get a couple more up here so we can play with them a little bit, and I'll show you how these rules work. This puts a little bit of a system into things. You know what to do first, second, third, and fourth, and if that doesn't work, it doesn't work. All right, let's have a look. The first thing you look for when you're given any question like this that says, name the next 3 in the sequence, right? It's a fairly common question. But unless you want to just look at it and hope, right, here's what to do first. Look for the same difference. That's what we found in the first one that I did on the other side of this piece of paper, right? You look at the difference between the two. Right? The difference between 4 and 12 is 8. The difference between 4 and 36 isn't 8. So we can cross that one off for this, but that's always what to go for first, right? Because it's the easiest one. The other thing to look for is a changing difference. Right? Sometimes the difference changes by the same amount. Let me give you an example of this. For example, 3, 6, 10, 15, 21. Now that's not the same difference. 3, the difference is 3 there. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. 15 plus 6 is 21. Look at this. 3, 4, 5, 6. Again, that's predictable, right? If this isn't predictable, that's hard to predict. This is easy to predict. You know exactly what's going to happen next. You're going to have to add 7, and then you're going to have to add 8. Right? So the next two numbers would be 21 plus 7, 28 plus 8, and you'd be right. Okay? So again, same difference and change your difference. They're the easiest ones to figure out first. Now in this case, the case we just had before, neither of those is working, so I have to go further. Now the same ratio one. Ratio is just multiplying or dividing. Right? So instead of adding, given that adding and subtracting didn't work for us here, right, we're going to try multiplying. So forget that. That's adding. We're going to go down here. 4 times what is 12? 4 times 3 is 12. Is that happening again? 12 times 3 is 36. Happening again. 36, trust me, 36 times 3 is 108. By the way, you're going to need a calculator for this. Some of these numbers get really big, and we don't expect you to do this in your head. All right? But we found it. That is a consistent thing. This is predictable. So it's just multiply the next number by 3. So you're going to have to grab a calculator for this. I can do it in my head because I'm a smart aleck, right? So that's 324. That's 972. And I probably can't do that one in my head, so I'm not going to embarrass myself. Right? But that's the answer. Easy ones first, then get a little bit harder. All right. Now look at this one. We'll worry about getting down to these last two when we need to, right? You don't even worry about having a look at the hard ones if you've already solved the question, right? And this is why the order of this is important. Always start with the easy stuff. The easy one might be the answer. Don't do anything hard, right? Start easy. Okay, let's have a look at this. Is it the same difference? 8 plus 2 is 10. 10 plus 2 isn't 13, so it's not the same difference. Is it a changing difference? 8 plus 2, 10 plus 3. 13 plus 4. This is looking like a pattern up here. That's plus 5. Yep, got it. 2, 3, 4, 5. That's predictable. We've got it. So you're going to add 6. You're going to add 7. You're going to add 8, and you'll be able to figure out the next 3. This is how this works. It keeps things as easy as they could possibly be by forcing you to go the easy options first and then only use the hard ones. Only try the really difficult stuff if you really have to. So having shown you that, I'm going to show you a couple of cases where you really have to get to the difficult end. Hang on a second. I've drawn these in red because they're scary. Okay. Swapping colors. Getting serious. These are genuinely difficult. Right? Most people who don't have a system, if you didn't have this, do that first, second, third, fourth, fifth, you could sit here for half an hour and not get this right. And it's probably only worth a couple of marks. And a lot of people sit here forever trying to figure out how on earth that is a pattern. Right? So for God's sake, save yourself the time. You can go through this entire sequence in about 2 minutes for almost any question. So let's do it. Same difference? Obviously not. 14 plus like 86 is 100. And 100 minus 80 is 20. So it's not the same difference. We're not going the same gain or the same loss every time. Changing difference. It's changing by a lot. That's plus 86. I'll stick it down there. That's minus 80. How is this going to be a pattern anyway? That's plus 60. No, there's no patterns forming in there, is it? It's not going 2, 3, 4, 5 or something like that. It's not going 5, 10, 15, 20. All right. Even if it was plus 10, minus 10, plus 10, minus 10, that would be a pattern. As long as you can see a pattern and you can know what's coming up next, as soon as it gets to the stage where you can tell what's next before you figure it out, you know you've got the answer figured. But that's not figured. Not that. Not that. Is it multiplying by things? Well, I don't even know what 14 times what is 100. We're not going to make it that hard for you. We're not going to make it so hard that you have to get out a calculator and look at an answer that's got a lot of decimal places. Because I'm telling you, 14 times, I think, 6 times 5973 is 100 or something like that. Right? We're not going to do that. So it's not that. And even if it was, let's say that 14 times 7 is 100. It isn't. Right? It's 7 point something. Right? Again, it's not going to be the same next, is it? Because that's 100 divided by 5 is 20. So again, that's not going to be a pattern. So now I have to go down here. Sometimes there are two interlinked patterns, and that means that these guys, the odd numbered numbers, are making one pattern, and these guys are making a different one. And it's almost like two different questions stuck together in the same line, right? This is difficult. So you just have to look at the blue ones now, right? 14 plus 6 is 20. 20 plus 6 is 26. That's the same difference. Look at this. That's one of those. So 26 plus 6, you have to jump 2 places because this is jumping 2 places, right? You have to keep the jumps correct, right? 26 plus 6 is 32. It's another one of the blue ones. 32 plus 6, and it's going to go over there. It's not the next number. It's going to go over here, is 38. Now you've got to look at the other guys. Red ones. 100. I wonder if it's one the same difference again. 100 minus 20 is 80. 80 minus 20 is 60. Yes, it is. They were both really easy. You just didn't know that there were actually two of them sandwiched together. That's what made it look really hard. It's actually two easy questions in one. So 100 minus 20 is that. 80 minus 20 is that. 60 minus 20 is 40. So that's what goes there. Not the easiest thing in the world. And you never would have caught that. You never would have seen it if you didn't know to look for it. And if you hadn't knocked off these guys. If you didn't know that it couldn't be that, couldn't be that, couldn't be that. Right? This is why I'm teaching you this sequence. This will save you from a lot of work for not much gain. Right. One more. This is a very cruel question. I made this one up. I'm rather proud of it because it's cruel. And I'm a maths teacher and I'm supposed to like when I torture people. Right? I'll tell you right now, if we went through all of this, we wouldn't get that, we wouldn't get that, we wouldn't get that, we wouldn't get that, we wouldn't get that. Right? Well, we wouldn't obviously get that. The last hope is that all the numbers have something in common. They don't necessarily follow a mathematical plan like add 3 or add 7 or multiply by 2 or something, but they've all got something in common. Like they might be all prime numbers, they might be all odd numbers. But, excuse me, they might be all numbers that can be divided by 5, but they're out of order, but they've still got something in common. These have got something in common as well. And I'm not going to tell you what it is. I want you to tell me what it is later on in the lesson. By the end of the lesson, if you can tell me in teams what these numbers have all got in common and tell me what the next 3 are, you, my friend, are a genius. I reckon that's one of the hardest questions I've ever given you. But there is your challenge. I'll see you in the lesson.